Welcome back to the channel. Today we're going to be kicking off Season 5 by moving forward with the petroleum battery conversion on this electric golf cart. If you're not familiar with the petroleum battery concept, well, the idea is to remove the heavy lead-acid batteries and replace them with a small gasoline engine and an automotive alternator. With the gasoline engine connected to the alternator, we'll be able to produce all the electricity that we need to power the electric drive motor on this golf cart. You see, the sole purpose of this conversion is to get the electric golf cart back on the road without using batteries. Now, this may sound like a bad idea, but despite the efficiency issue, we've proven this concept works much better than anticipated. You see, we spent the better part of a month testing and developing the petroleum battery concept, and it's time we take everything we've learned and apply it to this much nicer golf cart. Now, today, we're going to focus on how to mount the gasoline engine and alternator inside the body of this golf cart. As far as the electronics go, well, this diagram shows the simple system that we'll be using. Now, information on how all this works can be found in our previous videos, so we're not going to cover any of it today. However, we will cover it again in a future video. Today, it's just nuts and bolts hardware, and I'll explain a few different options that can be made to simplify the installation of the petroleum battery on this particular type of golf cart, which happens to be a 1994 Club Car DS with an all-aluminum chassis. Now, the aluminum chassis is really nice, but unfortunately I don't have the equipment, the budget, or the ability to weld aluminum, so some of you need to keep that in mind. Anyway, we ain't going to be welding any of the aluminum. Instead, we're going to be doing this conversion with simple bolt-on fabricated parts. Alright, let's get started with our first problem. The white wall tires on this golf cart are awesome looking. It's hard to believe they even offered white wall tires on these things, but as you can see they did. Now, the bad news is the tires are worn out and they won't hold air for more than a few hours. So in order to make the golf cart easier to work on, we're going to have to replace the tires so I can push this thing around the shop. Anyway, I was able to source a set of new tires for a reasonable price. Now, these new tires are slightly taller, which is nice because it'll help increase the top speed of the golf cart. Apparently on the Club Car DS, you really can't go much bigger than the stock size tire without having interference issues. Now, most of the issues can be eliminated with a lift kit, but that's a bit extreme. On this golf cart, we want to make it both comfortable and reasonably quiet. These new tires aren't anything special other than being slightly taller, and that's fine. Keep in mind, our main focus is on the petroleum battery conversion. So let's swap the new rubber in and get that out of the way. Wow, the front suspension's very interesting. You know, this is a lot more complex than I thought it would be. It's got a tiny upper control arm, a tiny shock absorber. Aw, how cute. For the lower control arm, it uses a transverse leaf spring. Now, I don't know anything about golf carts, but this seems pretty advanced for a glorified go-kart. I'm really starting to like this thing. I guess I should mention that we have no intention of making this buggy suitable for use on the golf course. Our project is all about making this golf cart a street cruiser, sort of a luxury go-kart for gentlemen. You know, I've driven some pretty fast and loud go-karts over the years, and I can still handle the noise, but my back can't handle the rough ride of those evil contraptions. Anyway, in my little town, these golf carts can be driven on the local roads, and I want to exploit the rules and have something that's just a little bit more interesting to cruise around in. But at the same time, I want to make this thing as quiet as possible, so the cops don't start looking for me every time I fire this thing up. With the data that we collected from the Kushman experiments and some updated math, well, I figure this thing will go 25 miles per hour. Now, is that going to be fast enough? Well, it's hard to say, but generally 25 miles per hour is considered the fastest safe speed that you can go in one of these things. Now, if you haven't seen any of the previous videos, well, you really should, but I'll give you an interesting nugget. The all-steel vintage Kushman golf cart was able to get 40 miles to the US gallon when we took it on a 10-mile adventure through the Kansas countryside. Now, fuel economy is not the goal of this project, and it'll be interesting to see if we get better or worse fuel economy with the lighter club car. Alrighty, the new tires have been fitted. Yep, the white walls definitely looked better, but the new shoes will hold air and that's good enough for me. Let's see if we have any interference problems with the taller tires. So that's full steering lock for a hard right turn. Well, that looks goofy. Is this thing set up for drifting? And yeah, we have plenty of clearance if we decide to do donuts in the parking lot. Yeah, donuts. Oh, so I forgot to mention, this thing is easy to push around the shop. Actually, it's a lot easier to push than the Kushman, so it'll be interesting to see how that affects performance when compared to the Kushman. Let's confirm that the electric motor actually works. Now, off camera, I went ahead and simplified the wiring because we won't be needing the DC motor controller for this simple version. Now, at some point after we're done experimenting with this thing, I have to put this golf cart back together, so I made plenty of diagrams to help me restore this thing back to normal. Anyway, let's see if the electric motor works. So if I touch these two wires to the battery, the wheels should spin. Let's see if that's true. And yeah, the wheels spin. So if I reverse the polarity of these wires, will the golf cart go into reverse? Well, let's try it. And nope, the wheels still spin in the forward direction. And that's because this golf cart has a series wound DC motor. You see, the way this golf cart is wired, the polarity to the motor doesn't matter. The wheels will always spin in the same direction. The only way to reverse the motor is to flip this switch. Now, flipping the switch actually flips the polarity of the field coils inside the motor. Now let's try it. Yep, the switch works and we have reverse. This is awesome. Reverse is a luxury that I'm not used to on most of my projects. So off camera, I spent a lot of time thinking about how we're going to fit the Predator engine and the alternator in this buggy. And it turns out this cross member is definitely in the way. The cross member is used to support the weight of the batteries, and since we're not going to be having batteries, technically I could saw this cross member out and have plenty of room for shenanigans. But I ain't doing that, and the reason is I have to restore this golf cart back to original condition when I'm finished with the project. You see, my brother's wife wants this thing for cruising the neighborhoods, and she's not exactly thrilled about the petroleum battery concept. So that's fine, I can work around this cross member. However, if someone was considering converting a club cart to the revolutionary petroleum battery system, well, it's way easier to cut the cross member and build simple motor mounts. If I temporarily put the body back on, you can see there's not a lot of room with the cross member in place. But it turns out there's just enough space to make this happen. Let's take a look at what I've been doing these past few weeks. So this table has all the necessary parts to mount a 212cc Predator engine in a Club Cart DS without cutting the cross member. Now if we did cut the cross member, well, we would only need a slightly longer mounting plate, and this, and this plate wouldn't be necessary. But we're doing it the hard way. So this is a 1/4-inch thick steel plate that we're going to be using to mount the engine and the alternator. Now this plate is heavy, but in this case the steel works out better than aluminum. Now on the Kushman, we use these bearings for a simple way to mount the alternator, but these bearings won't work because we don't have the space to use them. You see, the bearings should go here for a simple alternator mount, but these bearings increase the length of the mounting plate and we end up with an interference problem. So, we fabricated some aluminum brackets and that gave us the last fraction of an inch we needed to get everything to fit. Keep in mind, we're going to be using rubber motor mounts like we used on the Kushman, and we need the extra space to allow the engine to move around when it's running. So, we have to factor in for that extra space, and these aluminum alternator mounting brackets will give us the space we need. So this aluminum plate and this aluminum plate make up the front motor mount, and I'll show you how that goes together a little bit later. The rear motor mount, well, that ended up being super complex, and we ended up using 2 chunks of angle iron, plus this aluminum plate that has 2 low-cost Hemi joints and a generic exhaust hanger. So for the rear motor mount, we're going to suspend the engine and the alternator from these cross braces. The angle iron chunks are used to stiffen up the cross braces. Here, in this shot, you can see how it all fits together. So the rear mount goes here, and we'll stiffen up this section with the angle iron brackets. Now this section of the golf cart frame is intended to carry the weight of the seat, including the driver and the passenger. And we'll be asking it to carry an extra 25 pounds as a rear motor mount. Now, the bulk of the weight of the petroleum battery will be carried by the front motor mounts, so I don't think we'll be putting a burden on the seat frame. I think we're going to be safe, and with the reinforcements, this should be fine. Of course, all this could be avoided if we cut the cross member. Now, if that were the case, the mounting system would be so much easier. Anyway, this tiny bracket mounts to the alternator, and it's what we'll be using to suspend the rear of the petroleum battery to the seat frame on the golf cart. The bracket mounts to the 140 amp cheap Liberty alternator like this. This will all make sense after we assemble everything. Right now I'm just giving you a closer look at all the individual parts. So if we take a close look at the petroleum battery that we used on the Kushman, the only parts we'll be reusing is the drive pulley, this turnbuckle, and of course the alternator. Fast forward a few minutes, and I've assembled the new petroleum battery for use in the club car chassis. Now, this is just the petroleum battery, and we'll have a look at how it mounts in a few minutes. So if we look at the petroleum battery that we used in the Kushman and the one we intend to use in the club car, well, there's quite a few differences. In the Kushman, we were able to keep the tiny fuel tank, the factory Predator muffler, and the factory Predator air filter. Now on the club car, we have to use a remote fuel tank, a different muffler, and a different air filter. Of course, one of the big differences is we mounted the alternator behind the engine on the club car setup. This will keep the exhaust heat away from the alternator. Now, during our testing with the Kushman, we didn't have any issues with the alternator getting hot when it was in close proximity to the exhaust. And now we figure the alternator will stay extra cool. Also, the way the club car is set up, the entire engine can be serviced through the opening under the seat. If for some reason the alternator needed service or replacement, then the body of the club car needs to come off, which takes an extra 15 minutes. Now, I did mention that the factory air filter on the Predator engine can't be used. Let's take a look at our solution. So the way this engine sits in the club car chassis, the air filter will come in contact with the seat, and we can't have that. So we have to get rid of this air filter. The good news is there's a low-cost solution. An aftermarket air filter is available for the Predator engine, and this is something I picked up many years ago for another project. This filter and adapter can be had for less than $20 on the Jungle site, and it's just what we need. Now, for street driving, this filter will be fine. However, on dirt roads, there may be an issue. For now, I'm okay with this filter, but in the future, I may add some extra tubing and mount the filter a little bit higher. Anyway, here's something to consider when mounting the engine inside the club car body. Well, gaining access to the choke is going to be a problem. Well, I guess. I could just flip the seat forward, reach down and grab the choke, and it's not a big deal. But on this build, I want to try something different. This is a remote choke adapter for a Honda GX390 engine. Now, unfortunately, they don't make these for the smaller Predator type clones, but we can make this GX90 part fit the 212cc engine pretty easily. As you can see, I've already marked the location where we need to drill the new holes in order to mount this to the 212cc engine. And over here, this metal needs to be ground off to allow clearance for the 212cc carburetor. Now, these holes are going to be tricky to drill, and we could just use a file to stretch the existing holes. But I'm going to do something different. I have the adapter mounted to a piece of copper, and I'm going to weld these holes up. The copper backstop will allow me to fill the holes with the MIG welder, and the welds won't stick to the copper. Let's do this. Well, there you go. The old holes were welded up and the new holes were drilled. Now this gizmo will fit a 212cc engine. Now before we can install this gizmo, there's a piece of aluminum on the carburetor that needs to be snapped off. Some of the older carburetors may have a spring. Anyway, whatever's preventing this choke arm from moving freely needs to be removed in order for this to work correctly. Alright, let's put this together. This spacer needs to go on first in order for everything to line up. Next, the gizmo slides in place like so. Now, if you have an extra spacer, this is a good place to put it. Usually an extra spacer is included with an aftermarket air filter kit. And now we can install the air filter adapter. This is a cool upgrade for the 212cc engine with an electric start. Now the remote choke cable can be mounted right next to the starter switch. But we ain't going to be using a normal choke cable. Instead, we're going to be using a solenoid activated cable that gets triggered whenever the starter is engaged. I would love to show you how this works, but this magical device hasn't arrived yet, so we have nothing to look at today. Well, let's take a look at this. So this guy will need some modifications in order to work, but it's a cheap solution for the automatic choke pull solenoid. Actually, I bought two of these, one for the choke and one for the engine throttle. You see, this engine basically has two speeds. It's got idle and full power. Now, this may get confusing, but remember, on the petroleum battery, the foot accelerator is connected to the alternator and not to the engine. Anyway, when the golf cart is stopped, well, it makes sense to idle the engine down for less noise. Now, when the accelerator is pressed, well, that'll activate this solenoid and the engine will go into full power mode. Now, since this solenoid is going to be connected to the engine's governor, there's no issues with overspeeding the engine. If you recall, on the Kushman, we had a hand throttle for the engine, and that worked great. We could continue using that for simplicity, but I want to add this bit of automation because it's an interesting upgrade. However, it really isn't necessary. Alright, let's put this thing together. You know, some people can't imagine why I would do all this engineering and fabrication just to install the petroleum battery. They may feel it's far easier to buy replacement batteries and not have to bother with all this complicated stuff. Well, I reckon that's a fair thing to say. But replacing batteries on a golf cart is not why most of the audience tunes in every week. I reckon not more than 5 or 6 people would watch one of my videos if I just replaced the batteries. Meh, that's boring stuff, and that's not what this channel is about. You see, we'll go the extra mile to build a convoluted system just to avoid putting batteries in the golf cart. So if you like seeing outside of the box thinking, then by all means watch my videos. But if you want to see someone put batteries in a golf cart, well, I'm afraid you may not be in the right place. The thing is, some people find what I do to be educational, some people find it entertaining, and some people need something to watch while they consume their Captain Crunch cereal. YouTube creators provide the alternative entertainment that can't be found on mainstream TV programming. I created this channel because this is the type of entertainment I want to see. Okay, the rear motor mount for the petroleum battery has been installed. It'll be interesting to see how this mount behaves when the engine's running. Now, the reinforcement angle irons really help stiffen everything up, and that was the plan. Alright, let's take a look at the front mounting system. So this mount uses 6 rubber isolators. Now, we really only need 2 isolators, and I'm actually using the other 4 on the bottom as spacers. This works out perfect because we get a lot more flex in the mounting system, which will help reduce vibrations being transferred to the chassis of the golf cart. For now, I'm using fender washers so I can fine-tune the height of this mount. However, once we sort everything out, I may replace the washers with spacers. But for now, the washers work fine. So the front mount fits in the chassis like this. With all the washers and the rubber mounts, we end up with a little more than a ½ inch of clearance over the cross member. Now, if we did cut the cross member out, we'd be able to lower the height of the petroleum battery about 2 inches. If that were the case, we would still have interference issues with the stock muffler and the stock air filter. So no matter what, we would have to come up with a solution to replace them. At this point, we can slide the petroleum battery into the club car and see how it fits. Fast forward a few minutes and the petroleum battery is installed. Getting this engine and alternator to fit without modifying the chassis or the body of the golf cart wasn't easy, but it fits. Now this engine's been upgraded with an electric starter, so we really don't need the pull starter. Actually, the pull starter is somewhat useless, because if the little battery doesn't have enough juice to start the engine, then it certainly doesn't have enough juice to run the electronics. Now, in the past, on other projects, we found that removing the recoil starter actually helps the engine run significantly cooler. And that's because this helps increase the airflow to the engine. You know, it's hard to say if the engine's going to be running hot when the body's installed, but if it does, we do have a plan. Let's see how much wiggle room we have. Oh yeah, the motor mounts have plenty of flex. You know, on the Kushman, this made a huge difference as far as lowering the noise due to vibrations. So here's a close-up shot of the rear motor mount and how it attaches to the alternator. Now we chose the alternator to use as a mounting point because this alternator has a heavy-duty mounting bracket already built into the alternator case, and it worked out perfect for this application. So it may look like there's an interference issue right here, but that's just bad camera angles. There's plenty of clearance and no issues here. So the engine fits fine, but now we have to deal with the fuel tank. Well, no worries, the fuel tank will fit right over here, and right here is where the little 12-volt battery will go. So the fuel tank does sit a little lower than it should in order to gravity feed the carburetor. We figure the engine will starve for fuel once the tank drops to about half, so we'll have to use a vacuum pulse fuel pump. Now, since we need a fuel pump anyway, we could upgrade to a larger fuel tank, but for now this will work just fine. So far it appears everything fits fine. Let's put the body on and confirm that's still true. Alright, let's take another look. Well, it actually looks like the engine is supposed to be there. Not too shabby. Also notice we have access to everything on the engine, so maintenance and upgrades will be easy to do with the body installed. Now on the other side of the engine, well, we still have issues with the exhaust system, so let's look at some options. Getting an exhaust system to fit is going to require some fabrication for sure. The stock Predator muffler, well, it sits too high when it's installed on the engine, and it'll come in contact with the bottom of the seat of the golf cart. Plus, the outlet's pointing in the wrong direction, so this ain't going to work. Now this is a common shorty header for a 212cc engine, and this one points in the wrong direction as well. Now this is a custom fabricated header that I made for another project. Let's see how it fits. Well, it's pointing in the right direction, and with some modifications I could get this to work, but this puts the hot exhaust close to the battery compartment, and we need to keep this area open for future experiments, so this isn't the answer. Now I did some poking around on the Jungle site, and I found this header. In a picture they used for an example, they show this header on a mini bike, and it looks like this actually may work with a few modifications. The main modification is of course the outlets pointing in the wrong direction. So this pipe would need to be cut around here, and this lower section would need to be spliced back on, pointing in the other direction. This header might be the answer we're looking for, so I went ahead and ordered it, and it should show up in a few days. Now the muffler that comes with this kit is complete garbage. These mufflers are noisy and they don't do anything for power. Anyway, we won't be using this muffler. Instead, we'll add an extension pipe here, and we'll install a quiet muffler from a generator. Since I don't have anything to play with right now, let's do some clever editing just for fun. Okay, all the junk from the ad has disappeared, and now all we have is the pipe. So we want this pipe to drop down into this hole. Of course, I'd have to relocate the wires, but in the real world, that's not a problem at all. And now let's install the pipe. Well, it may or may not fit. Turns out we don't have enough information, but I'm confident I can get it to fit with a few modifications. I think for me it would be easier to start with this header than to try to build something from scratch. So the 212cc engine that we're using makes 6.5 horsepower in stock form. Now these engines can be easily modified to produce 8.5 horsepower with some carburetor, exhaust, and ignition modifications. And with some internal mods, well, they can make a lot more power. This dusty and unloved engine is a prime example of a high horsepower Predator engine. Many years ago, this modified engine was installed in our Honda Insight project car for some high-speed testing. At the time, our goal was to get this street-legal 212cc powered Honda up to 50 miles per hour. Now, in Michigan, anything that runs and drives is street-legal. So, yeah. Anyway, as you can see, we were able to get the goofy-looking Honda up to 54 miles per hour with a 212cc engine. As I recall, it took a while to get the car up to speed. Later, we put the engine on our test dyno and ran it through a series of tests. It turns out this engine was developing just over 12 horsepower. Now, this engine was equipped with a high compression cylinder head, stainless steel valves, stiffer valve springs, a billet connecting rod, a performance camshaft, and the ignition timing was advanced quite a bit. The carburetor we used was a VM22 knockoff. Overall, the engine ran great and made decent power. But here's the thing, in order to make a lot of power with one of these little engines, you have to have an unrestricted exhaust system. Or, in other words, the exhaust will be extremely loud. So how much power can you make with a quiet exhaust? Well, I'm not sure, but likely no more than 8 horsepower. Anyway, earlier I said this muffler was garbage, and it is. We tried this one on the Honda and on the dyno, and it's both loud and it restricts power. The muffler that we used on the little 212cc engine is a Yoshimura knockoff, or possibly the real thing. That information is a little bit sketchy. Anyway, that was the best muffler we could find that reduced the noise somewhat and didn't rob the engine of any power. But it was still noisy. Actually, we liked this muffler so much, we put it on the 670cc Predator-powered Renault. Donuts. Anyway, I'm aware that the 212cc Predator can be modified for more power. You see, I've been there, I've done that, and I've made YouTube videos about it. But on this petroleum battery build, we're going for quiet, and there are limits to how much power we can get from this little engine. However, if you were considering building something similar to our project and noise isn't an issue, well, then it's possible to get a lot more power from the engine. But keep in mind, the governor must be kept in place. The governor is actually a critical part of how the system works, and without the governor, there would be no automatic load compensation, and the system just wouldn't work. Now, if you disagree with me, well, don't tell me. Instead, it would be helpful if you research the purpose of the governor on these small engines, and you'll find that they're for automatic load compensation while maintaining a set RPM. And that's exactly what we need for the petroleum battery to work. Anyway, this project's coming along great. The engine and the alternator are installed, which is probably the most difficult part of this conversion. I feel like the exhaust is going to be extremely simple once the parts arrive, and I'm looking forward to getting this rig running again. So if you're new to the channel and somehow you made it through this entire episode, well, in order to make this electric golf cart move with a gasoline engine and alternator, that's the simple part. You see, all we have to do is connect this little power supply to the alternator and connect the accelerator pedal to the power supply, and the golf cart will come back to life. Now, the best part is, the golf cart will never need batteries again, and the performance will be a lot better. Since the petroleum battery can easily generate more than 36 volts, well, the top speed will actually increase. And despite the energy loss that's inherent to the petroleum battery, well, the golf cart is actually fuel efficient, and on the prototype, we achieved 40 miles to the US gallon when we drove the Kushman at full throttle through the Kansas countryside. All in all, this appears to be a great way to salvage an old golf cart and give it a second life. Hopefully today's video was both entertaining and educational, and perhaps this video will help you with your own project. I had fun today and I hope you did as well. We'll see you next time. Until then.